Alright, in this video I want to finish up understanding some of the theory behind working with linked lists, and then I think we'll be ready to plunge in and write a lot of code that works with linked lists. And I think the theory is not so bad, so let's get that out of the way, and then it's going to be writing code that's a little tricky. So we saw in the last video how to represent a linked list pictorially with one of these box and pointer diagrams, and for some reason I seem to have lost part of this arrow. Oops, there we go. Okay, so this represents a linked list with the values A, B, and C in it, obviously, and we saw the code to construct that list. And what I want to do now is I want to challenge you to answer a question about linked lists. And let's see, okay, no problem. Here's my question for you. I want to ask you how many nodes I need for a given number of data values. So, number of data values and how many nodes I need for that number of data values. So suppose I have 3 data values. How many nodes will I need to store 3 data values? Excuse me, terrible cough. Alright, how many nodes do I need to store 3 data values? Well, I need 3 nodes, right? Obviously, I just saw I had 3 data values and I had 3 nodes, 1 node for each data value. No problem. Okay, I didn't trick you there. How about if I had 2 data values? How many nodes will I need to store 2 different data values? Or maybe 2 of the same data value? Well, 2, right? A linked list with 2 nodes. Okay, how about if I want to store just 1 data value in a linked list? What would that even look like? Well, we'd have a node whose next was null, and that stored our 1 squiggly data value. Right, so I would need just the 1 node. Let's get rid of all that mess. Okay, just the 1 node. Okay, now the super challenge. What if I have no data values at all? And this is a legitimate thing to want. I might want a linked list that is empty, that has no data values. For the same reason I might sometimes have empty strings and empty array lists, whatever. I'll definitely find myself with empty linked lists frequently enough. How many nodes do I need to store 0 data values? And I've found sometimes some of you watching this video may be thinking to yourself, oh, well, this is a trick. The answer is 1. You still need at least 1 node. It's just that node will be empty, right? Maybe it'll store null or something like this. Its data value will be null and its next value will be null, right? This is a linked list with 1 data value. And that 1 data value is, I guess, null. So that's not correct. If you want no data values in a linked list, you need no nodes. No nodes at all. So up here, when we created our linked list with 3 nodes, we said node list equals, then we made all those nodes. Let's see what that line of code would look like for an empty linked list. Ooh, let's make some more room by making this line shorter too. Node list equals. What am I going to store in that variable list if I want list to be empty? List is empty. That's just a comment. That's not actually the code. We still need to figure out the code. What am I going to store in that variable? Well, I can't do this because that would lead me down the path of making a new node, and apparently if I have no data values, if my list is empty, I shouldn't have any nodes. What's the only other value that I can store in the list variable, in a variable of type node, that isn't itself a node? That's right, null. So, null is the empty list. Null signifies, it sounds more important than is, signifies the empty list. Whenever we have an empty linked list, we use the value null to represent that empty linked list. This is probably going to bother you, and I think this takes a lot of getting used to. In fact, this is very different than things we've seen before, right? If you think about the other sort of data storing structures we've probably seen so far, we have strings, we have arrays, depending on what order you've watched whatever videos or what order the class that you might be taking is going on, you might have seen array lists. And in each of these situations, it meant something to have an empty string, right? An empty string, that quote business, right? An empty string, you can still ask it, you can ask how long it is, right? Its length is 0. You can ask an empty string for its length. You can test if it's equals to something, right? You can call the equals method, right? So empty string is not the same as the null value. Null means you don't have a string. Quote, quote, this means we have an empty string, a string that has no characters, but it's still a string that we can ask various questions of. And likewise, an array, we can make an empty array, right? Here's a new array of 0 integers. And I can ask this array, how long? Right, by saying dot length on that array if I have a variable that refers to it. And that's pretty much all I can do, I suppose, with that array. If it's an array list, so I do something like new array list of, I don't know, spatulas. There we go. There's an empty array list of spatulas. It holds no spatulas yet. It's empty. But I can still ask how long, right? I say dot size, and I can still test, I can add to it, right? I can still call the add method and I can put something in it, right? Array lists let me do that. So there's a difference between having an empty string or an empty array or an empty array list. There's a difference between that and not having a string or not having an array or not having an array list and simply having the null value. That is not the case for a linked list. Linked lists are completely different. For a linked list, null means empty linked list. There's no difference between an empty linked list and the null value. And that means a linked list isn't something you can ask, well, what's your size? What comes next? Or whatever. You can ask that of a node, but if your linked list is empty, you can't ask anything, right? Sorry, you can ask get next of a node anyway. You certainly can't ask a node for its size. So this is a pretty wild idea. So it's going to take some time getting used to the idea that null is the empty list. And I just wanted to make you feel like you're in good company if you're bothered by that. But over time, you'll find it's the most beautiful idea, right? It's the most beautiful idea. Let me show you something else about this null value. And here's a recursive definition. A recursive definition of a linked list. What is a linked list? Someone asks you what a linked list is and you want to seem like a smarty pants. Here's what you tell them. A linked list is null or a node whose next refers to a linked list. So there's a nice circular recursive definition of a linked list. Either your linked list is empty, excuse me, either your linked list is empty, in which case you just have the null value, not even a node, or you have a node and the next inside that node refers to a linked list, right? Let's see if that's true. Does the next always refer to a linked list? So let's go back to our picture. Here, the next of this node is indeed a linked list, right? These two nodes here comprise a linked list. So it is a kind of recursive idea. And the next of this node, called B node, then its next is also a linked list. It's a one-element linked list. But here's the really deep thing. The next of this node here is also a linked list, right? Because its next is the null value, represented as a slash when I draw it in these diagrams. Remember, this diagram is simply short for this longhand diagram that I got tired of drawing, and you will get tired of drawing this stuff too. So you'll like these box and pointer diagrams. The next of the last node is null, and since null is the empty list, the next of this node is a linked list. So that's what we mean when we say linked lists are recursive. And here's our lovely recursive definition, or circular definition depending on how you look at it. Alright, I have a little bit of time, so let's talk a little bit more about linked lists so I can get all my philosophical garbage over with. Why on earth should you study linked lists? Why linked lists? Let me give you 3 reasons that I personally think linked lists are important, and maybe just one of them will resonate with you. First idea, linked lists are beautiful. Beautiful. They're elegant, they're beautiful. What's so beautiful about a linked list? Look at, when we had strings or arrays or array lists, these were probably magic to us. They came with the language. We don't really know what goes on inside them. although depending, you may know what goes on inside an array list, and if you do, that's great, but we don't really have a sense of what's inside a string or an array unless we get into how memory is managed and how the programming language works and so on. Whereas we know exactly what's in a linked list. A linked list is, let's see if I can find that slide for you. Whoop, sorry, scanning through all the things we've ever typed about linked lists. A linked list is it just consists of these node objects. And we can make these node objects. We fully understand these node objects. So, going back to where we left off, linked lists is a beautiful idea because we understand where they come from. We understand how to build them from scratch, from the ground up. We don't need any fancy arrays or array lists or whatever built into our language. We just need to be able to create objects that pair data values with nexts. Second thing I like about linked lists is linked lists are more efficient than arrays or array lists. Wait, hold up, I'm not done with that thought. You may be thinking, that's not true. They're more efficient than arrays and array lists in some situations. There are some scenarios where it is a better choice to use a linked list than it will be to use an array or an array list. And we'll see those as we continue to study data structures. For now, you'll have to take that on faith. The third reason we care about linked lists is I think linked lists provide a foundation for understanding other node-based data structures. There are other data structures that consist of nodes that are not linked lists. They might be doubly linked lists, they might be circularly linked lists, but eventually we'll see that we can make a data structure called trees, a data structure called a graph, and trees and graphs are based on nodes, and if we understand linked lists, we'll be pretty comfortable working with trees and graphs, and trees and graphs turn out to be extremely useful for solving a range of problems where trees and graphs end up being much more efficient ways of storing data and manipulating for certain kinds of problems. And so if we understand linked lists, which are a very simple node-based structure, we can work our way up to understanding more sophisticated ones later. So for all those reasons, we're going to care about linked lists. In the next video, we will finally write some code that works with linked lists and get a feel for how to solve some linked list problems in Java code. I'll see you there.